In this problem, we are looking for an SAT score that is equivalent to scoring a 26 on the ACT. So to solve this problem, our first goal is to try to figure out what percentile is an SAT score of 26. So what K percentile is this? And once we know what percentile it is, we'll know where that SAT score sits on the SAT distribution. So let me make a sketch of the distribution for all SAT scores. And let me go ahead and write down that standard deviation of 229 points. And we're going to mark that score, right, on the right tail, kind of in the same position as an ACT score of a 26. And we can see, hopefully you can see now, I know my drawing is not to scale, but the shaded area in red on the ACT, this should be the same as the shaded area that is on the ACT distribution. And so once we know what percentile an SAT score of a 26 is, we can use that same percentile because it'll be the same on the SAT distribution, and then we can work backwards to find that SAT score. So to do this using your graphing calculator, we're going to use the normal CDF function. So normal CDF, which gives us areas under the normal curve. And here what I'm going to do is I'm going to try to find the area that is actually shaded in blue. Okay, and I'm going to use a lower bound of -1E99 and go all the way up to an ACT score of 26. So my lower bound is -1E99 up to 26, mean score of 19.4 and a standard deviation of 5.4. And when you put that into your calculator and press enter, it gives us an area of 0.8892. So that means that blue shaded area is 0.8892. And then if we subtract that from 1, if we take this and subtract it from 1, the area to the right, which is in red, gives us an area of 0.1108. So that means that an ACT score is in the 80, oh, let's round that to 89th percentile. So this puts us in the 89th percentile. So that means that I am looking for an SAT score that also sits in the 89th percentile. So the area to the left of that unknown SAT score is also going to be 0.8892. And so here, now that I know the area, on my calculator, I can use the inverse norm function where I can put in the area that is to the left of the unknown value, right? Make sure I put in the correct mean and standard deviation value. And then using that graphing calculator function, it is going to give us a corresponding SAT score of a 1303.9, which we can round up to a 1304. If you're using z-scores, then at this point here, you would need to find the corresponding z-score that corresponds to an area of 0.8892 on the left. And so going to the z-table, that gives us a z-score of 1.22, and then we can use that formula. X is equal to 1.22 times our standard deviation plus our mean value, and putting that into our calculator, which will also give us a score of 1303.38 or 1304.